Hello, everybody. How are you? We'll continue working on the ministry, the grade 8 ministry exam. Last time we have solved 3 problems, but we have discussed the basic concepts and ideas that help to understand the problems and find the solutions or answers. The problems are here to assess your understanding of those concepts discussed. So today we will continue with more questions. I will read you the questions. Two of the questions are related to graphs, motion graphs. Okay, motion graphs. Actually, motion, one is in general about motion and the other is about motion graphs. So I will discuss how we can use motion graphs to solve problems, to find out quantities from graphs, motion graphs. Okay. The first question is, what do you call the rate at which the velocity of a body changes in a given interval of time? This is about motion. How motion of an object is described using kinematic terms. Okay, kinematic terms, in general physical quantities. So to describe motion, to describe motion, we need physical quantities such as time, okay, duration of motion. In this case, duration of motion, how long the body moves, okay, it is important, moves. It is the time measured from the beginning of the motion to the end of the motion. The time interval between the beginning and the end of the motion of an object is time. The second is distance. Distance is the length of the path, okay? The length of the path followed by the moving body or object. In this case, you follow the path, okay? You have to measure along the path the body moves so that you can find the distance the body covers. This is scalar, doesn't depend on direction. It only depends on the points touched by the moving body along the way, from its initial position to the final position. Third is displacement. Basically, displacement is the shortest shortest distance the moving body covers during its motion. The shortest distance the moving body covers during its motion, or we can say the shortest distance between the initial position and the final position of the body. The initial position and the final position of the body. Okay? Scalar vector. And the fourth one, the fourth physical quantity that we need to describe motion is speed. The speed basically tells you how fast or how slow an object moves in any direction. Okay, you need not to know the direction of the motion, but what you need to know is it moving faster or slower? Is it moving faster or slower? It tells you how far an object moves in a given time interval. Okay? How far an object moves in a given time interval. So we can say it is the rate of distance covered in a unit time. In a specified unit time. Per second or per minute or per an hour. Okay? So speed is simply distance over time. Actually, we can have instantaneous speed at each instant of time, at each movement. We can say at the first second, the second second, after 2 seconds, after 3 seconds, after 4 seconds, and such measurement is what is going to be instantaneous speed. And the other one is average speed. Average speed is the speed which collectively tells you the average value, which is total distance over total time. So here we talk about speed, which is total distance over total time. And if we think the motion is uniform motion in a straight line, instantaneous speed and average speed are equal. Okay? And here average speed can be given just total distance over total time. The fifth physical quantity that is used to describe motion is velocity. Velocity is sometimes given as speed plus direction. And this is true for uniformly accelerated motion in a straight line. Because magnitude of speed magnitude of velocity and speed are going to be equal, so only direction is important. Only direction is going to be added. So velocity is displacement over time. Displacement over time. And here we have what? Here we have average velocity. It is vector, okay? It is vector, and it tells you the rate of the coverage of displacement in unit time. The rate of the coverage of displacement in unit time. During what? During motion. During motion. The 6 is acceleration. Acceleration is the change of the time rate of change of velocity. When velocity is not constant in the uniform motion, basically uniform motion in a straight line, which is in a fixed direction at constant speed. In that case, velocity is constant because direction is fixed, magnitude is the same or constant. But in uniformly accelerated motion and in non-uniformly accelerated motion, there is acceleration basically. In this case, acceleration is going to be time rate of change of velocity. So A is change in velocity, V final of initial, or change in time. This tells you how the velocity of an object changes with time. It can be adding, increasing, it can be decreasing. When the velocity increases, it is acceleration, positive. When the velocity decreases, it is negative acceleration and usually called deceleration. Okay? So, question number 4. After we describe the physical quantities used to completely understand motion, the kinematics of motion, we can answer question number 4. What do you call the rate at which the velocity of a body changes in a given interval of time? A, average displacement, B, average velocity, C, average acceleration, and D, average speed. So the answer is acceleration, which is average acceleration, C. C is the answer. Okay, C is the answer. So find out if this is helpful for different question papers of different years. Maybe you can see related questions from 2011, 2012, 2013, and before 2010 as well, and use this discussion to answer similar questions. So my objective is to help you understand the concepts so that you can easily answer the questions without confusion. The second question, again, which is related to motion size, if actually the slope of distance time graph in which s is in meter and time is in seconds is numerically found to be 5. Which of the following is correct about the value of this slope? It says. So what we have to discuss here is motion graphs. So we have distance time graph, we have velocity time graphs. Okay, so let me start with uniform motion. In uniform motion, what we know is that velocity is constant. It has one value from the beginning to the end. And the definition for this kind of motion is the distance covered by the moving body for equal time interval is always going to be equal. It covers equal distance in equal time intervals. Okay, velocity is constant. So how can you draw the graph? You generate, just assume that you have V as an example, let me say 6 meters per second. 6 meter per second. Okay, you have 6 meter per second, which means if you have a table basically here, let me say I have velocity in meter per second and I have time in second, meter per second here second. Okay, when time is 0, I know that velocity is 0. When time is actually there is a value, so time 0 means we are not measuring after all. So when it is 1 second, 6 meter per second. When it is 2, how much do you think? When it is 3, how much do you think? Okay, we generate because we have this and we know that V is constant. It is going to be 6 all over the values of time you take. 4, 5, 6, 7, 8. Okay, 8. So if you have a graph, what kind of graph? Velocity time graph. Velocity time graph, basically you have velocity at each second or at each instant, and which is the same, and time actually goes as there is motion going on. So VT graph basically means we have the graph to be the independent variable. The independent variable means the variable which stands by itself, which is time in seconds. And this is the dependent one. We calculate it from time, but basically there is acceleration V initial plus AT, and T A is 0 means you have constant value. Okay, so it is dependent on time. So if you have 1, 2, 3, 4, 5, 6 velocity in meter per second. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can go that way basically. A little bit. Should be uniform. Okay. 1, 2, 3, 4, 5, 6, 7, 8, let me say. Correspondingly, you have values. Oh, sorry. For 1, you have 6. Okay. For 2, you have 6. You can see. For 3, you have 6. For 4, you have 6. For every time you measure, you have 6 meters per second as a value of speed or velocity, it doesn't matter. You see, so this is what you call VT graph for uniform motion. Okay, as you can see, V is parallel to time axis. The graph is parallel to time axis. Slope in mathematics, slope is equal to vertical increase over horizontal increase. In this case, change in velocity over change in time. Change in velocity is 0. Velocity doesn't change. Time can change. You can take this 3 minus 2 or 3 minus 1, you have t value changes, but velocity doesn't change. Therefore, slope is automatically 0. That's why the graph is horizontal. The graph is horizontal. So usually we say the velocity time graph of uniform motion is parallel to the t-axis. Slope is 0, which means acceleration is 0. Okay, and the area under velocity time graph, this area is equal to the distance covered as distance. You can calculate this one as S is equal to Vt. Okay, this is V and this is T. It is a rectangular. Therefore, S is equal to Vt means equal to the area. So area under the curve and the total distance covered are equal. Only when the motion is uniform. Only when the motion is uniform. Okay, so the next is The next is graph of uniformly accelerated motion. Okay, we can have actually distance time graph. Sorry, distance time graph of uniform motion. Uniform motion. We can talk about distance time graph. ST graph. ST graph. ST graph. So S is equal to Vt, and we can have the same table, okay? The same table. Here we have S in meter, T in second, okay? Therefore, when time is 0, it is going to be 0 automatically. So when T is 1, we can say initially both are 0. There is no initial position given. When time is 1 second, V is 6. Okay, we already said 6 meters per second times 1 second. Second by second is going to be off, so it's going to be 6 meters. When it is 2, second by second cancels. 2 times 6 is 12. 3, 18. 4, 24. 5, 30. 6, 36. And 7, 42 meters. I think you can draw this one as well. You can draw this, okay? You have T here in seconds, which is independent, and you have ጥገኛ ያልሆነ ወይም ኢጥገኛ ተለዋዋጭ ነው ይሄኛው ደግሞ ጥገኛ ነው በማን በጊዜ ማለት ነው። So dependent, it is dependent variable, this is independent variable. Always the horizontal is going to be the independent one. So you can have 1, 2, 3, 4, 5, 6, 7. Okay, and you can have here maybe I can say 6, 12, 18, 24, 30, 36, and 42. So now it is different, okay? The first is this one, at 0 it was 0, and the second time 1, 2, 3, 4, 5, 6, 7, 8 it goes, and you can have go this way and you have this one, and go this way and you have this one, okay, and go this way you have this one. It continues like that, and when you connect them you will have a straight line through the origin, okay. This is ST graph, the ST graph for uniform motion. Slope is V here. Vertical slope is equal to, slope is equal to vertical increase over horizontal increase. Vertical increase is distance, okay. For example, if you take 12 minus 6, consider this one. The vertical increase may be this one, okay, and the horizontal increase may be this one. So draw this. This is horizontal increase and this is vertical increase, okay. So this is 6 minus 12 minus 6 is 6. This is 2 minus 1 is 1. 6 over 1 is 6. So 6 meters per second is the slope, which is, take any value from the distance, two values corresponding to values from time, find the slope, and the slope is going to be 6 meters per second because it is a straight line, so it has constant slope, and that is what it is. Distance time graph, the slope should be what you call velocity or speed, doesn't matter, but it is constant, it is 6 meters per second. So the slope of distance time graph for uniform motion is a speed. It is a speed, okay? It is a speed. Therefore, if you are given that value, you can talk about the speed. The The slope of ST graph, in which S is in meter and T is in second, is numerically found to be 5. Which of the following is correct about the value of this slope? A. The total distance covered is 5 meters. B. The acceleration is 5 meters per second square. C. The velocity is 5 meters per second. D. The total time for the motion is 5 seconds. The slope of ST graph, like this one, the slope of ST graph, okay, the slope of ST graph, in which S is in meter and T is in seconds, is numerically found to be 5. Numerically. It is a kind of 6. Which of the following is correct about the value of this slope? The slope of ST graph is velocity, always. Velocity, or you can say speed, it doesn't matter. So the answer is again C. The answer is C. Okay, for today, this is enough. We have 2 problems, but we have seen concepts. So the concepts are helpful to solve or answer different questions, not only for this booklet, but for booklets from different years. Okay, so try to solve other similar questions using these concepts from different booklets. This is my channel for today. Thank you very much. See you with another video.